I'm pretty sure most of you have solved this question using an approach called as two pointers, but we'll be solving this question using another approach, an approach we just learned, and that is hash maps. So I'll be answering two questions. Why and how is hash map a solution? Well, coming to the why, hash map using hash map, the problem can be solved with a much lesser time complexity than the one you solve using the two pointers. Now, how is hash map a solution? Well, using two pointers, you would be iterating the array many times. You would consider one number after the other, and for that number, you would be iterating the whole array. And in hash map, you would be iterating the array only once, and that makes it a solution. You would be iterating over the array once, and you would be finding the solution. Now, let us come to the logic. Well, the logic is we'll just see the what the question says. We are being given an array. This is a nice rectangle box, and let us consider the test case itself. 2, 7, 11, and 15. This is an extra box. Well, the question says that we are being given a nums array and also a target, and we have to find two numbers present in the array such that when they are added, they give the target. So, in the test case, we are being given the target as 9. So, this is the array we've been given 2, 7, 11, and 15, and the target is 9. So, what's the logic? Well, in using hash map, we are to find the pairs which lead to the target. And for that to be done, we need to calculate a complement, and we should we should search the hash map for that complement. Now, what is a complement? Well, in hash map, using this approach, since you would be iterating the array once, you would be only knowing one number. In two pointers, you would be iterating the array using two loops. So you would be knowing both of those numbers. Now, in mathematics, uh, when you are finding a third number, let's say a gets its value from being b and c getting added up. Now the target is a, and the other two numbers are b and c. Now we know what is b and also know what is a, so we need to find what is c. So we would be doing b, sorry, uh, a minus b. So similar logic follows. We know we are iterating the array, so we know the current number. So we know the current number and also we know the target. We need to find the other number that when we add that number to the current number, we get to the target. So let us say 2. The current number is 2. So we need to find the other number. So 9 minus 2 gives the other number, which is 7. So the main idea is that we need to find the complement, we need to calculate the complement and find it in the hash map. And if it is present, we would be returning the indices of both the complement and also the current number and also the complement. And if not found, we'll be returning an empty array. So let us code. First we will create a hash map, let us name it hm and new hash. So now that we have created a hash map, we will be requiring to iterate the array. So int I is equal to 0. Now we will be iterating the array. So the first thing is that we will be going to calculate what the complement is. And as we saw here, the complement, let us name it as int comp. Now the complement is going to be target minus the current number, which is nums of I. After we have calculated the complement, we would be checking whether it is in the hash map or not. If it is in the hash map, if hm contains key nums I, sorry, complement, we would be searching for the complement. Would be searching for the complement, and if it is found, then we would be returning an array, since the output requires an array of the indices of both the numbers. So we would be returning an array int, and well, this is one of the ways you can create an array. So new int, square brackets and flower brackets, map dot get sorry, hm dot get uh, scom hm dot get complement and the index of the current number. With this, we will be getting the index of the complement. Now, what we are going to store in the hash map is uh, the current number and also the and also its index. Now, you may ask, why not the complement? Why only the current number? Well, if you are storing the complement, you are storing a number which you are uncertain of, and in DSA you have to solve the problems with surety, clarity and purity. So you would be having clarity and purity, but not surety. Now what is unsure? When you calculate the complement, you are not sure whether the complement exists in the array or not, but the current number exists in the array, you are sure of it. So you would be uh, liking to put the current number, the number which you are sure of, into the hash map. So hm dot put uh, nums of I and its and the current numbers index. So for example, let us uh, see see the logic in action. The first thing is that we have an array 2, 7, 11 and 15, and the target is 9. So when the i's value is 0, when I is equal to 0, the number nums of I is 2. Now complement is equal to target minus nums of I. So comp becomes target, which is 9, and nums of I, which is the current number, which is 2, and that is 7. Now initially the hash map's size would be up to 16 initially, because we haven't given what size it should be of. So the initial size would be 16, and initially it would also be an empty hash map. So when you try to find this complement, it wouldn't exist in the hash map because it is empty. So what we will be doing is, if it is empty, we would be uh, adding this current number to the hash map along with its index, which is 2 and 0. Okay, so we would be adding key and value pairs. The key is 2 and the value is 0, which is the index. And when it is the turn of the second one, when I is equal to 1, the current number, which is nums of I, would be 7, and the complement would be 9 minus 7, which is 2. Now we'll be checking this 2 in the hash map, and if it is present, well, it is present, then we would be returning the current numbers index and also the index of that complement, which has been recorded as 0. So we would be getting 1 and 0 as the output, or 0 1 as the output. And if even after calculating and iterating over the array, if there are no pairs of numbers that lead to the target, we would be returning an empty array. So let us run this. So yes, we got the array as 0 and 1. Let us submit. Yes. So now I want to ask you all a question. Can we solve this using hash set? As you explained. Yes, that's what I'm asking. Hash set. Well, the answer is yes, but the thing is, the time complexity will remain the same as the two pointers. How? Because hash set would not store the indices. You would not be storing indices in the hash set. Instead, you would be storing the numbers only, which are not the duplicate, of course. And for that, to find the index of the complement of the number inside the hash set, you would be needing to run another loop inside the first loop, which is to iterate over the array. So nothing changes in the time complexity if you use hash set. You It would remain the same as of the two pointers.